Welcome to A-Level and AP Physics, a place where you can improve your understanding of physics with confidence. In today's video, we will talk about Newton's laws. And this is second video on Newton's laws past paper questions from Cambridge AS Physics. This question is about Mass-Pulley system, and Mass-Pulley system questions are very common in A-Level physics and also in AP physics. These questions are simply based on Newton's laws, especially on Newton's second law. Let's try to find out what is given to us for this question and what we need to find. So in this question, it is given to us there are two blocks. One block has mass capital M, the other block has mass small m. And they're joined by a thin string, means string has no mass and also it is inextensible. And the pulley is frictionless, means pulley has no friction. So what we can conclude from here, so simply based on this data, we can say that capital M is greater than small m, and as the string is thin, is massless, and the pulley is frictionless, it simply means that T1 has to be equal to T2 and it has to be equal to T. So later we will discuss what is T1 and what is T2. And A1 has to be equal to A2, and we can simply say this is A. And because as the string is inextensible, so both masses, they have the same acceleration. So let's try to draw the free body diagram for this mass small m. As you can see, its weight is acting down. We can say this is mg, and the tension in the string is acting up. So that's the reason it will accelerate upwards. So it means upward force has to be greater, and this is the tension. We can say T1. For this mass, we can also draw the free body diagram. As this mass is greater, it means greater force is acting down and there is a tension that is acting up. So this one is T2. And it is accelerating down, it means downward force is greater. So let's try to draw the free body diagram for small mass. For small mass, simply we can say as upward force is greater, so we can say the T1 minus mg has to be equal to m times A1. And for the bigger mass, we can also draw the free body diagram. As you can see, we already have free body diagram. We can write down the resultant force. So this is mg minus T2, mean mg is greater than T2, and this has to be equal to capital M, means the mass of that block is capital M, and acceleration we can say is A2. As we simply understand, A1 is equal to A2, as you can see here, we have already written here, and T1 is equal to T2. So simply if we add these two equation, let's say this is equation 1 and this is equation 2, if we add them, simply we can cancel. This T1 is plus, this T2 is minus, but T1 is equal to T2. So we can simply cancel these two. So what we left with mg minus small mg, and this is equal to small m plus capital M, and we can take common A. A1 is equal to A2, so we can simply take common A. So we need to find A, so we can simply say that capital M minus small m, and this is multiplied by G divided by capital M plus small m. So this is how we can find the answer. And so in this case, answer will be B, as you can see here. So this is our answer. So this method is little long, but if you have understanding of this one, so we can also use a shortcut method. Simply we can say A has to be equal to F net, means the resultant force acting on the system divided by the total mass of the system. So in this case, as we can see, these two forces are acting in opposite direction. One is acting on the left side this is acting down, and the other one is acting on the right side, and also this is acting down. Actually these two forces are acting in opposite direction. So it simply means we can write down mg minus small mg. So this is the resultant force acting on the system, as pulley has no friction. And what is the total mass of the system? As the string has no mass, so total mass of the system is capital M plus small m. So this is how we can find A directly with this one. So this is a shortcut way we can simply use, and we can find acceleration of the system. This is our second question, and this question is about a street lamp. A street lamp that is attached to a fixed wall by a metal rod and a cable. So as you can see here, the cable is here and the metal rod is here, and the lamp is attached at this point, and here is the wall. So what we need to find which vector triangle can represent the forces acting at point P, and here is point P. So for this one we simply need to understand the forces acting at point P, and also we need to be careful with direction of forces. Now the first force we need to understand acting at this point is the weight of the lamp. The weight of the lamp is acting down. We can say this is W lamp. And there is a force acting on the rod actually from the wall, and this force is acting to the right. We can say this is F rod, mean horizontal force of the rod. And the tension in the cable is acting in this direction. So based on this one, simply we can answer this question. So as you can see here, this direction is up, so this is wrong, this is also wrong, and this direction is to the left, this is wrong because it has to be to the right. So this is also wrong. Now our answer can be B, or an answer can be D. So let's first of all look at B now. This is good, but this is also good, but this is wrong. Direction of tension actually is wrong. So this can't be our final answer. So look at this one now. This is correct. Direction of horizontal force of the rod is also correct, and direction of tension is also good. So our best answer is D. And this is our final answer.